Do we have everybody here? All right. So Patrick Bridges from University of New Mexico graciously agreed to lead this panel.
Yeah, a long time ago, yes.
Very long time ago.
Right, there you go. All right, so the basic idea here, and let me go ahead and get started, is to just have a Q&A session so the various audience and people can ask the members of the teams questions they have, issues they are concerned about, just have a more general open discussion about making use of these systems, the research it enables, the concerns that people have, how to meet their needs and your needs so the projects make some good success. So, I mean, basically, we want to open this up to the audience and start with any opening questions people might have. So, go ahead.
Okay, I have this group at the top. What's the cost for get on one cloud platforms, and is there an approval process?
Yeah, there's a mic here, right? So is this? No.
Let's just start. There's always a cost of
Yeah, maybe. Yeah. But yes, there will be allocation policies, at least at Chameleon. So the way you get an account in Chameleon, we right now have it open to future grid users who need to migrate very quickly. But by the end of the year, it's going to be open to all users or all people who want to use Chameleon. When you create the account, you'll see what the process is. You first create a project, which you describe what kind of research you're going to do. So you share some of the experiment design. You're going to get a startup allocation, which is essentially going to be designed to allow you to publish your first paper. And you will also submit for later allocations. So later on, you will be able to use that and publish papers. And like Dan said, there's cost. NSF is paying for it. We're going to create policies that will try to ensure fairness among users.
Could I just add?
Yes.
Yeah, for us, and I'm not sure I speak for Cloud Lab on this, but the idea is that when we get more requests, then we're able to satisfy that the advisory board will review the request process. So it won't be the project team making the allocation decisions. We'll have a community advisory board that reviews the allocations and prioritizes up to until we run out of nodes in time.
So the process for Cloud Lab is pretty much the same. We have the sign up form online now. You can go ahead and submit an application, and mostly for the most part, we're going to do approval at the level of project, right? So you kind of tell us what project you want to do, but we're not going to approve every single experiment. For particular experiments that might need to use some large fraction of the facility, or that want to run on a semi-permanent basis or on a very long period of time, those we'll deal with on a case-by-case basis with an approval committee. But for the most part, we approve the project, and then the set of experiments in that project is up to you. all probably, the whole thing probably not. A substantial chunk of it probably. So I do expect that we're going to have some semi-persistent. So something that I didn't really kind of skipped over in my talk was, I do expect that we're going to have some set of research projects that come to us and say, look, we want to do some kind of cloud architecture research, but then we also want to open it up to people, right? So that they can come use this resource, and then we get actual workloads, and we kind of get like 2 bits of research done on the same set equipment at the same time. And so I would imagine that we're going to have some resources that get allocated to those that are not going to be just taking them away quickly. Another facility that I'll just mention, because Keith mentioned it earlier, that if you, and Wyatt knows about this facility well, but if you if you do want a 1,000 node cluster that you can have the whole thing of, that is perhaps not a cloud type cluster, but is more of a an HPC type cluster, there is this probe facility run by the New Mexico Consortium and Los Alamos that does allocations at that level too. So so we will support big ones, right? But I don't foresee us giving the entire facility to one person at a time. Do you want to say something different?
Sure. So from our perspective, we would like to, we're going to have to obviously load balance between users. We're emphasizing scale, so we definitely want to be able to give users the ability to allocate the whole large allocation. We do want to support some long-running projects, so there may be times when all of the test bed, absolutely 100, all of the test bed, longish times may not be available. That's why I was talking about advanced reservations. However, we're going to have to see really what happens when the rubber hits the road and how the test bed gets utilized. It's always possible that those long-running projects could be accommodated at the, say, Chicago partitions, and other projects could be accommodated large partition at TAC, right? The ones that want a significant number of resources. And a pro test bed is, of course, a wonderful test bed, but last time I checked, they didn't have many nodes with hardware virtualization, and this is what our users are going to be doing a lot of research on. Okay. Okay. Yeah, they don't. They should be working. Okay. Okay. All right. So the question was, what about the use of testbed for educational purposes, where maybe it's not the case that somebody wants to allocate a large partition, but a lot of users may show up at the same time. And currently you're using Amazon, and you would like to see if you can use Chameleon. So one aspect to the answer of the question is we're trying to be not Amazon. And in other words, if you can use Amazon and if you're happy, then maybe you're not happy. Well, why are you not happy? It doesn't provide other things. So if you're using Amazon and it doesn't provide things and you're not happy, then it's very interesting to us, and we would like to provide the facilities that you need. Again, this is one of the cases when we need advanced reservations, and what you're telling me is that you would be interested in a mechanism where maybe a project lead makes an advanced reservation and then that gets parceled out to class members in the middle, right? And that's an important requirement. So thanks for bringing it up, right? Yeah.
I mean, from Chameleon, from our side, I think we also realized, we will get, as Kate mentioned, we started. I think I was talking to one of the audience. Education is very important because at the end of the day, if you build a system and your users, which is your graduate students and the society, they are not up to speed, then it takes us to actually enable those. So what I am actually working on, and I started actually with our own university first to basically deal with all the scar tissues before reaching out and building a community. I'm in the process of actually building a community. Feel free to send me email. I want to actually add you to that community. What I've done, you saw an arrow to UTSA. So I got a very large, Chameleon site, cluster also. So as we rolling capability, I built education there. And I was anticipating that basically we're going to get to that point. So I actually work right now with Oren from Mock, with a couple of even colleges. I want to even take it to high school. So feel free, we are building a community, and I love to actually not repeat the same thing. For example, if you're working on the networking classes, someone else working on security classes, someone else work on, big data classes. So The intent is through that open source education community on top of this, we could have overlapping and, and then use other resources that it's simulating the requirements and give you basically the whole experience of the Chameleon.
I wanted to say on the Cloud Lab side, we're very, very interested in additional educational uses. We're building off of the track record of Genie educational classes, and the use of a project for a class that can then have sub accounts allocated for the students is well established. The virtual machines, you heard a lot about the bare metal capabilities, which allows for lots of reconfiguration. That's right. And for this kind of lots of students, often if virtual machines will do, then using the virtual machine capability allows us to take these physical nodes and multiply by a significant number, and thereby support a large number of students.
Dan wants the.
Since we're recording, let me get this. So yeah, I'd like to echo that we would very much like to have your class project on the system. I think all of us would. But just in general for the allocations, large versus small, since we've gotten a lot of questions along this vein, I think a couple things to consider. We have, between us, the two projects, several tens of thousands of cores. There's 8,760 hours in a year. We will come up with some allocation unit and formula for, I need this many resources and I need them for this duration, and we will pack in as many of those as we possibly can. In my experience, you do some interesting bin packing, when scheduling large systems, where there'll be bursts where we're clear the system to do very large allocations. Those usually have to wait a little longer to get started if you're doing the whole system. Things that are flexible will schedule faster, et cetera, et cetera. So, but I think it is worth mentioning, right, that NSF is putting a pretty significant investment into these two platforms, order $20 million over the next couple of years. So when you say, I need the whole system for 2 months, that's essentially asking for $1.5 million, right? And so you need to think about that in context, right? And people will be prioritizing, if you have a collection of huge grants and you need, the equivalent of 1,000 hours of time that's likely to be highly successful. If you have some exploratory work not supported by a grant and you need 30 million hours of time, that's likely to probably see some cutbacks. So it is worth, thinking that although these are free to you, they are pretty large and valuable resources, and we want to, use the time wisely. So just think about your requests in terms of that scale. And again, with the help of the community on our respective committees and advisory boards, we'll allocate them as best we can. So.
Right. So the question, so the question was about storage in these systems, especially for educational classes, and how to deal with the fact that storage in these systems, for example, over the course of a semester for the class is a permanent resource, not the sort of ephemeral short-term configuration of network flows that like Genie's been using. Somebody want to take that? Rob?
I'll start with that. Okay. So I have a couple of, so two different answers to that. So one of the things that we have, had experience with in running classes on this kind of infrastructure before is one of the things that I, make my students do when I use I use like Genie for a class is I actually, is I make sure that they have everything automated so they can actually get back to the point where they were if the, if their, resources come and go, right? And this has the advantage of making the use of the resources more efficient, but it also is actually really good for disciplining the students, so that they don't just do a whole bunch of stuff and forget what they did, and so and for a lot of classes, even if you have large data sets, those data sets may not be ones where like the actual content of the data is that important, if you know what I mean, right? So like you may generate some large data set to do a computation on, but maybe you can actually generate that on the fly, and copying it around isn't necessary. So for classes, I would encourage you as much as possible actually to try to work in a style and get your students to work in a style where they can get back to where they were with relatively little effort, even if the resources they had were taken away. And the profile feature that we've developed for Cloud Lab is also, I mostly talked about it in the context of research, but it's really also very much for education. So you can have a link and you can say, look, follow this link, hit the create button, and you'll end up with your own copy of these resources. And in that style, again, we can, often we find that students don't need to actually hold resources for as long as they believe that they do.
So everything Rob said is completely true, but let me give a Chameleon answer. We actually will have 2 classes of storage and many flavors within those 2 classes. But one is in sort of our shared persistent infrastructure. We will have a few petabytes. I think we have 3.6 raw of a persistent storage tier, which is meant for long-term storage of data. And then we have allocatable storage servers within the individual compute units for the more ephemeral uses of, I want to create, something with the version of Swift that's not going to be released for 2 years and try that out. So, but within the persistent storage, we'll have, some of that will be used for image storage, obviously, so you can save your VMs or your bare metal images. But some of it will be file system and some of it will be object store. And the notion there is your data will reside for as long as you have an allocation on the system. For the allocatable storage nodes, I want to do my crazy new version of distributed object store. It'll be allocated like anything else. You'll sort of be burning your allocation while you're on those times. So for your class, I think you'd probably want to use the more, hey, we need persistent home directory storage, and an amount of that that's over the life of, our allocation. So, anybody else?
Right, so the general question is on elasticity of resources. Is there an ability to, to shrink and grow these allocations in a more elastic manner?
So the answer to that is yes, within the limits of the test bed, right? So if you're running an application or if you're running an experiment and somebody already allocated, other people are running, and you cannot scale within the test bed, then obviously you're not going to get resources. If there are resources available, you can add to what you have. Absolutely. And you're within your allocation, right? Yeah.
Hi, I'm Eric Heidi. So I just wanted to add, so in the context of the test beds that the University of Utah operates, right, we sort of have a 2-level authorization and allocation system, right? And those things are separate, right? So when we refer to an experiment, that's generally talking about an allocation of resources, right? And you as a user of the testbed can run multiple experiments at one time, right? So if you find that you have to do 5 different things, right, you can get 5 different allocations, and in that sense, you get elasticity, right? So if you have a particular allocation, okay, and then you want to add more nodes to that allocation, right? That's a different kind of elasticity, right? And that's not one that we have some support for that. I don't know what Rob wants to say with regards to special elasticity that we would design for adding VMs to existing stuff, but I just wanted to point out, right, that the easiest way to do elasticity, right, is to just start another experiment, run multiple experiments that come and go as your activities need them to.
Well, rather than talking about the technical aspects of elasticity, what I will say is one thing that we have to realize is that there is a different kind of economic model at play here than if you're using a commercial cloud, right? Because if you're using a commercial cloud, so long as you can keep giving them dollars, right? You know, up to some very gigantic limit, they can keep giving you stuff. And because, dollars aren't at play from experimenters here, right? We end up having to have other systems like quota systems or allocation systems or first come first serve systems because our resources are limited and we have to have some way of making sure that everybody who needs to gets to use it.
So the question was, has anyone tested saving a profile and loading it as a Chameleon application? So I think I'll.
So it's actually very hard. So first of all, it's going to be Chameleon Appliance. So first of all, I think you're correct that that Cloud Lab profiles and Chameleon Appliances capture, roughly speaking, the same concept. We didn't have time yet to explore whether there are any similarities or differences. If those concepts in fact are as similar as they look, of course, it would be fantastic if we could provide interoperability between those. These things typically come at a price, but would be presumably a good price to pay to allow users to move from one testbed to the other.
So we have implemented a system that lets you take images that are running in EC2 or in a copy of OpenStack and import them into our testbed. One of the people who has struggled with this most is sitting right in the middle of the room, and so he can tell you it's not like it's trivial or easy, but that is something that we are paying some attention to because most of the technology that we've built in the past, operates around the assumption that you start with one of our images and customize it. But of course, people are more and more interested in bringing their own images, that's one of the areas that we're going to put some effort into.
So to repeat the question, it was the issues of what lock-in and what features to support in terms of migrating from these services to more commercial or larger scale or other platforms? Okay, so go ahead.
I was going to comment that I think that, as Rob said earlier in his talk, we're looking for cloud researchers to take a look at new clouds. But a lot of that cloud research is going to be validated by the applications that you can then run on those new clouds. And so a key part of what we're doing, I think everyone up here, is to see how well we can support new and interesting applications that require some of the new capabilities that you're talking about. And from that standpoint, we're certainly interested in running at least demonstration and test size applications, even if that takes a longer period of time, and even if that reserves some resources for a longer period of time, because we do want to be able to understand those workloads, prove out the cloud architectures that support them, and be able to take that as lessons to learn and move forward. And I think that you heard earlier today in the National Science Foundation part that there is a phase 2 to the NSFCloud program where this would be scaled up, and presumably at that time more serious, longer-running domain users may also be invited. But I think at the current stage, we're definitely looking at getting a very good sample of real applications against novel cloud architectures.
So first of all, very good answer. Absolutely, we do want to attract applications with interesting requirements that are not covered by mainstream cloud computing. We're very, very interested in that, and pair you with researchers who work on those capabilities, and then hopefully create a relationship with industry that can address those capabilities. So DK, for example, is developing those wonderful infinite band drivers. Mellanox is adopting them, right? As the research becomes more solid, it's a sort of pipeline that users who are very experimental users within a few years could become part of the mainstream, and we will make sure that it moves there. And I know that Paul would like to address this question because that's essentially part of his role, is to ensure that the capabilities that those users need go into industry.
I think very good question. At the end of the day, if we look at next 5-10 years, clouds that they are not they don't have interoperability, or they don't have the same language of API with other clouds, they're going to die. It's exactly the same way that in US, there was a time that they were building roads. So we got to basically, as cloud builders and enabling the research academia to be part of this, honoring that the industry clouds such as Google, Amazon of the board, they're going to stay. And when you really want at a scale, it has to be interoperability, moving your workload or images from one to the other based on your needs. I mean, part of it is, that's why we are going to invite, as part of the advisory board, 3 levels, industrial research from all the way from CERN to Google research to Microsoft research, and from the cloud builders, we're going to invite companies, that they are, the plus side that I see, both projects, they are using OpenStack, which means, they will use the baseline of the APIs. So we will invite a lot of industry, basically companies that they are building the new generation of the basically clouds, from the BMW to Boeing, as part of the advisory, to make sure they help us. There's an integration. But one more side, if I wear my Rackspace hat, cloud at the earliest stage, we want you to push the limits, because what industry designed 5 years ago as a cloud, it may not work. So we want, you to go design the new APIs. So if they don't have it, we don't want to have that limitation that we are bounded by their capabilities. The good thing is there's an advisory board. As we discover a new way of expanding this horizon, we want to have the dialogue and conversation, but at the same time, we want you to be free. So if some of the cloud, as we heard, like Amazon doesn't provide it, you not be limited to the capabilities.
Mike, did you want to add something briefly?
Yeah, something slightly different. One quick observation I want to make, actually, because I think it's a fun observation. When you look outside, you can actually see the C&O canal, right? Which was one of these technologies that became absolutely quickly obsolete because the train system came around the United States, right? So that's why it's important to have research beyond operational systems. Coming back to clouds, actually here, I want to emphasize what Rob said earlier in his presentation, is the instrumentation, right? We will offer you guys instrumentation tools on power consumption, on all kinds of things. And so you can actually, now you can, like, for example, if you're interested in network performance, you can see everything that's going on until you hit Amazon, right? But in our case, you can actually look from the inside out, or vice versa. And I think that's an interesting aspect. And you can actually compare that with what with what you see in commercial and public cloud. So I, just as a side note here, as an interesting aspect.
So the question I got it. Go ahead.
So accelerators like FPGAs and GPUs were mentioned in applications. Not clear about the scale of
Right. So the question's on the scale of accelerators in each of the 2 projects. Somebody want to? Okay.
So it is very early to determine exactly at what scale we will deploy those accelerators. It also depends on the demand for them. It is not clear that everyone is really wanting to use them, or what kind of a user base we'll have for those kinds of accelerators. So we are still testing the waters in that respect, talking to a lot of people. Me and Rob have been doing this. There is some amount of interest in adding FPGAs to do the kind of work that came out of Microsoft earlier this year, and to do GPUs to, accelerate certain parts of, let's say, MapReduce and other such applications. That said, it is not easy to slice these resources and hand off different slices of an FPGA board to different users. So we'll have to be careful in terms of how much effort we put into engineering these things into our test beds. At this point, I would think that maybe 1 or 2 servers in each rack in Cloud Lab at Wisconsin may have FPGAs or GPUs, but a lot of it would be driven by demand from users and experimenters such as yourself.
So yeah, that's all very true. Our initial scale on all of those, the scale is pretty much 8 is the general answer, right? I think we have 8 K40s, we have 8 PHYs, of 8 Xilinx-based FPGA boards in the initial deployment, just so it's out there. And then yeah, we have some reserved funds to deal with growing that perhaps as usage happens. Some of them may be a little bigger. Xilinx has actually offered to do additional FPGAs if we'll buy the nodes, so out to 32. So the sooner you get in sort of user requests around those things, the more input we'll have for future phases as to how much we want to have. But at least on day 1 of the scaled up operations, which for us is by summer, we'll have at least 8 of each kind of accelerator available in nodes in there. Slightly more on things like atoms and arms.
And this is something where you can kind of help us understand what kind of scale you would want, right? I mean, so, you know, on FPGA boards, right? I mean, do you need 1? Do you need 8? Do you need 100? You know, and that'll help us do our planning, both for how many people want to use them and how many each experiment needs.
Get your friends to ask for it too.
So just to comment on, depending on what you want to do, you can look at Exceed. They have very large Xeon Phi systems, GPU systems, not FPGAs as far as I know, but those are for computational science. I think everyone's welcome. But if you want to play with the kernel and that sort of thing, you can't do it there. If you just want to use them, they have a lot of hardware.
Right. Yeah. So the question is about bare metal controllability of things like power parameters and similar kinds of. Right. Okay. Yeah. So that might, we'll work across.
I'll give the microphone back. No worries. So yes, absolutely. So we have some discussions, and we've been actually looking already in the hardware that's being installed in Utah. Me and my team have been working on a Genie project for measurement and instrumentation, and also experiment execution, and have done this for quite a while. And so we're building tools for the users, for the experimenters, that will allow you to do exactly what you just said: scaling of the CPU frequency, also measuring what power you're using, what power the server's using, capping power, right? So you can look into kind of green data with center research and so on. Yeah. That you can measure the individual server power. I don't disk power and memory power. I think we have to go back and figure that out in detail. I'm not 100% sure.
We'll answer that on the way to passing this to the next person. So yeah, it depends on our hardware. I'm not sure that we have anything that lets you do like memory power. We do actually have some switches you can measure the power on, though, which is important and something people often overlook because those switches don't give you that capability. Yeah. Right.
Yeah. So more or less the same answer from Chameleon. BIOS via the normal BIOS CLI tools. We will let you reset the BIOS to do those things, and if sensors will make the event logs and everything available. What we're not doing is any extra instrumentation within the servers for physical measurement points, and we didn't have any plan at the moment to rewrite BIOS tools to make anything else available. But if you could buy the server and set it yourself, it's something we will let you set. Mm-hmm.
So the question was about security and public-facing versus private-facing IP addresses.
So, of course, we're going to do our best to keep this thing secure. On the other hand, it's a test bed, right? And so, you know, if you want to do research into improved security for cloud, great, right? And that's absolutely supported. If you're going to store classified information on it, we don't make any promises that it's that safe, right?
Store classified.
Yes, yes, yeah. That's a better way of saying it. You know, we do like the Genie project, for example, has spent a lot of time on identity and authorization security, right? And so, you know, we're pulling in a lot of that stuff, and you know, because for the most part we're allocating, you know, a server to a particular user at a time, right? You actually do have, you know, pretty good security in that sense of, you know, there's no other tenants that, you know, maybe can figure out how to break out of the hypervisor, like with the Zen bug that existed, you know, a couple months ago that everybody had to reboot because of. You know, with the virtual and physical machines that you run, you know, how well you manage that security is kind of, you know, up to you. And
Hi, I just wanted to quickly add, so, I mean, security has many facets, right? And a lot of the security that we provide, right, in our test beds is one of isolation, right, where different experiments can operate concurrently, right, and they don't have they don't impact each other, right? And of course, we provide user authorization and those sorts of things, right? But I want to add that there's a responsibility on the users of the test bed as well, right? I mean, you know, with great control comes great responsibility. And so, for instance, we have long experience operating a number of test beds that give people public IPs, right? And if people, you know, install databases on there and they say, well, you know, it's server and no password, right? They get broken into. And we have to deal with this quite a lot, you know, I mean, operationally, right? We have to do this. So neither facility, I think, can take complete responsibility for the security of your own experiment. I mean, if you open yourself to the world, you will be hacked, right? So you need to be cognizant of what's going on. That said, right, we actively monitor for abuse and you know, take corrective actions. So.
Right. So quick answer as the above. Right. We're gonna provide the regular type of credentials for authentication authorization, but in terms of network isolation, when you run on the OpenStack cloud, you're gonna get IP addresses just like on any cloud, right? So you're gonna have full public network access there. When you're running on bare hardware, we're going to give you an isolated partition. At the beginning, it's going to be L2 isolated partition. That's beyond the early users phase, where we might even do just L3 isolated partition. Later on, we'll provide open flow capabilities to provide isolation. You know, on future grid, and on hotel, we would have about once a year an incident when somebody would deploy a virtual machine image and forget to change the administrator password on that. You know, it was downloaded from some public site. The intrusion detection systems detect very, very quickly whether something is happening or not. We're of course going to be running those. User typically gets a very stern conversation after that. We do have terms and conditions that say you're not supposed to do those things, and we will spend some training to make sure that users don't do that, right? But if we give you root access and if we put you on a public IP network on the OpenStack cloud, we essentially have no way to prevent that sort of thing, right? So we're relying a little bit on users and their care. Did you? Okay.
So regarding the training, you know, my great example is with both platforms, you're the driver. So how well as a driver you drive, it's important when it comes to security. From the education side, our goal is to actually create use cases So, default use cases with templates so people, they could take a look at different scenarios, because really you're in charge of defining your control plane and data plane and how you want to design it. So having some references, it helps. The other thing that I got commitment from Dr. Ravi Sandhu, he's in UTSA. He's actually going to run a security, he's the inventor of access control. He's going to actually try to bridge it and find cases, because, every system that you design, they have flaws. So we are trying to basically find cases that we miss and try to start incorporating it again from the education side.
Thanks. So yeah, Kate covered most of this, but as you mentioned, we will do public IPs. I do expect it to be a security nightmare. The very first thing we did was put the system in a zone of our network where incidents don't count against my production systems and against my center security score. But that said, we will be doing, we have a pro cluster, a clustered approach, so even at 100 gigabit, we'll be doing line rate on every packet. So while we will let you get into any kind of trouble that you want, security-wise, we will reserve the right to turn things off when the IDS flags them, unless you've made special arrangements that you really are intentionally trying to run a denial of service experiment on your machine.
Another thing that I think is kind of related and I didn't necessarily talk about much in my talk earlier, is that all of our Cloud Lab clusters have at least 2 networks. So they have one network that faces the internet, and on that one, we you can get a public IP allocation. We treat public IP addresses as allocatable resources, and you can ask for them or not. And then on the other side, on the experiment network, which is where most of the bandwidth, where most of the interesting stuff is, that's a private network. It's isolated, at least with VLANs and maybe with separate switches from other people, and you can run whatever you want to on that network, right? So if you want to run a denial of service attack against your own machines on that network, you're completely free to do that. We really don't care, and you can use, it's layer 2 isolated, so or even layer 1 physical hardware isolated, so you can use private addresses on it. You can pretend to use public ones. We really don't care what traffic you send on that network.
So the question is about basically sensitive data and the ability to use. Right. Right. So basically, cooperation with IRB boards and with the experimenters to support the requirements of board. Somebody wanna? Yes. Somebody's scared of.
Yes, we will provide such support. Yes.
So Chameleon says yes.
I mean, if you need us to document our practices or whatever for IRB, we'll do that. Going back to the earlier conversation, this is not really a system that is designed for very sensitive information, though. So if you need documentation, we can provide documentation.
Yeah. Next question.
I do a lot of work in performance engineering, and doing it in the cloud is a really interesting challenge. I wonder, is there going to be access to hardware counters and things like that?
Yeah, absolutely. I mean, if you can get it with, root on a machine, normally you can, that's what you'll have. So in fact, you can get those things. And some of the power monitoring stuff we've been talking about is, sometimes you have stuff that is part of the chassis manager rather than the CPU. So the CPU stuff, absolutely, we're not going to get in your way. And then for the chassis management kind of sensors, we'll be providing an interface to those.
Will you be? Will there be some way to to control the exogenous noise that from other things running on the system that you guys are running, so that I can actually get numbers out of.
So the the default is you have a physical PC completely to yourself, right? And any storage that's attached to that PC, is also completely yours. If you're going to use any centralized storage, then there's a little, then of course there are other people. But for the kind of work you're talking about, I think you would just want to allocate your own exclusive PCs, your own stuff. For the network piece, one of the things I mentioned earlier, some amount of the network is shared, but one of the things we are going to work on is, because we do have some of these switches that we have out of band management capabilities for the switches, if you needed to run an experiment where actually the switch was yours and nobody else was running on it, we can do that kind of stuff. And I don't know, Aditya, do you want to say a little bit about, like, is there more that you want to say about, like, the queue length, monitors and that kind of stuff, which would be kind of the network equivalent of some of these ports?
I think whatever Rob said about having access to actual physical machines holds for having access to switches as well. Whatever you can monitor by having command line and CLI access to a switch, or maybe with some other deeper instrumentation, you should be able to get those counters out from switches as well. And same holds for storage and other parts of our cluster. We will release a list of features of these switches. Right now we have a documentation going on, a documentation effort going on, where we are listing the open flow specific features, where we want to add a little bit more about the specific sets of hardware features that HP, Dell, and Cisco devices allow you to monitor, in addition to the open flow support, and that would be available to the general users, so that you know what else you can monitor on these network devices.
I think from the Chameleon perspective, we will give the exact same level of access. And I just wanted to comment that I think in both of our proposals, as we conceive these, that limitation of production clouds is what we saw as one of the 5 or 6 basic use cases and drivers for how we built the system, right? You really do need, so our intent also is to not share physical nodes within a user's allocation, right? So your hardware, up to the level of a rack and a switch, you get a quiesced, quiet system with no other access to it. You can measure the things you need to measure. Performance measurement was one use case. Control is the other, right? You can't change the stack inside the cloud. And I think you guys would agree with me that in both of our projects, right, that was a fundamental motivation. So if you can't do that right, we're not doing our job right, and ask us to change something.
So the question had to do with, you might have kernels that have different, capabilities. One kernel has the right stuff to measure some hardware counters. Other ones might have the right drivers for InfiniBand. So we mostly deal with this by, you're in control of the kernel, right? So if you don't need InfiniBand and you want to measure performance counters, that's fine. Install the patch kernel that has, the stuff that you need, right? In terms of in terms of, like, are we going to do a lot of, like, effort to, like, reconcile different kernel patches and stuff? No. The vendors that we're working with, so just to give you an example, so working with HP, we have these kind of exotic 64-bit ARMs that are not that common. Well, those guys work with Ubuntu to make sure that all, like, the stock Ubuntu kernels have everything that they need to run on this particular platform. So anything that you can apply to any module you can load or patch you can apply to a stock Ubuntu kernel, has all the, will work with all the drivers and stuff you need for our particular platform.
So opt-in capabilities. That is, there's always going to be something exotic. There are super sensors for power at all levels. Someone mentioned, what about memory power? In both environments, you'll have opt-in capabilities. So you can run general experiments in the general environment, but have an option to add your own exotic equipment and sensors.
Either way. We're going to say the same thing.
Probably. Yeah. So I just wanted to say, whatever we are trying to give you an environment that will be as near to you owning the machines and having them in your lab as possible, right? That doesn't mean that, as Rob said, we will reconcile patches from vendors and make sure that everything you want is in that environment, right? In some special cases, we might, in research that we particularly want to support and we cannot do it otherwise, we might go that route, but it's not part of the general service.
So you do mention a real and particularly onerous problem, and I will say on our other production systems where we reconcile, InfiniBand with specific hardware with everything else, we usually start with the stock rail kernel and we do 70 to 75 patches to make it work. But Rob led off with the right answer, right? You have control of the kernel, so in that situation you can do one of two things: build a custom kernel that has both features, or run one kernel and take measurements, reboot the machines, install your other kernel and take measurements on the same suite and measure the other thing, and either one is fine in the context of an allocation. I think there's, behind it.
Just a really quick comment. If you do build such a kernel, make it available as a profile so that others can use it.
Yeah, I actually had the same comment. If you do this, share with everyone else. And also ask us ahead of time. Maybe we've already done it. So Dan mentioned this exact problem in InfiniBand and hardware counters. We happen to do that elsewhere in other systems. People can help you with that. I mean, we will be there to support you. We can't support you for everything, but we'll do what we can.
Okay. Go ahead, in the back. Right. So the comment was to make sure that he was very happy to have the benchmarks available to make sure you remember the database benchmarks and things like that. I'll chip in a question. One of my concerns as somebody that works on the bare metal side a lot is when you start futzing with the BIOS that I run on a machine and it's in some oddball state that someone else has left in from their previous BIOS experiments. Thoughts on reproducibility and isolation sort of across time with all the state on these systems?
Yeah, for me, we've been down those same wars, Patrick. So the word we use is sanitize when you come out of them, right? So we will have a default configuration with a saved BIOS state, and our theory is between blocks of user runs, right? When we take the machine back from you and give it to the next user, that we will run a sanitization. I'm going to say script, but in fact it will be a collection of a large number of scripts that bring the machine back to a sane state, run a quick, stream HPL type performance test to make sure the machine produces the same results it did going in, and do all that essentially between allocations. So there'll be a little bit of overhead for that, but yes, stepping the CPU speed down three steps and then giving it to the next user is not that much fun. So.
I mean, I have the same answer that we sanitize stuff between users. One thing that actually I had not considered, but we might want to consider doing in light of that question is we actually have a boot process that it actually uses the TPM to checksum the BIOS and the BIOS configuration, all that kind of stuff as it boots to make sure that it's actually bit for bit what we think it is. I hadn't considered using that in Cloud Lab, but maybe we ought to. I'm not sure whether actually the Clemson and Wisconsin nodes have TPMs, but if they do, maybe we ought to look at that.
Other questions? We're getting close to out of time, but so let's try to keep it a little brief. So, So go ahead.
Yeah. So the question is, if you develop something for one of these platforms, how easy is it to take it out and run it someplace else? So, really what we're doing here is we're running at a layer underneath a typical cloud stack, right? So if you think about I develop something that works against the particular set of APIs and abstractions that OpenStack has or something like that, right? So you can run OpenStack inside of Cloud Lab, or you can run Eucalyptus, or you can run cloud stack or any of those other stacks. So at that level, right, at the level at which people normally think of things, right, you're actually interacting with a set of with software that you kind of get from anywhere that you want, right? And so there's no lock-in there. Now, if you think about, we do provide a set of APIs for like provisioning cloud. So if you wanted to build a cloud that can be provisioned on one of these things, we do have a particular API. But for the most part, we kind of expect that the cloud software stack is the artifact that you're actually doing the research on.
Based on experience and also seeing both system they are using, APIs, it all comes back to the application. If your application is cloudified, you're writing Ansible or any of the Puppet Chef, and you're really deploying it in an automated way. It all comes back to basically speaking English or French. That's a part that it might be some of our API extensions, no matter we are using OpenStack mode. That's the part that you have to basically check. But assuming if your application is cloudified, I think that's one of the challenges as a lot of basically academia, like companies, we are facing it. There's a board of people that basically they use the cloud, but they use the cloud the old way. Probably 90% of the market is still. The one that they design their application like Netflix, that it uses the entire capability of a basically cloud, you see only the new cloudify application. So I'm hoping with this new systems, we're going to get a lot of those stuff that you had one application that regardless even in one platform to the other platform, you may face issues. It's just the old application, they didn't use the decoupling that, clouds bring to the table. And hopefully this is the beginning that as we see some of the people, they are running experience on both of them. It's a new era of actually having application that they are cloud independent. They really run on multiple cloud and they decouple themselves.
I think we have time for one more question. There was somebody right in here who wanted to go ahead. So wait.
So in other words, you don't want to maintain it, you don't want to put the hardware in your institution, or you want to put the hardware and get our software? Okay. So you want to give us hardware? Yeah, we'll be delighted. Yeah. It's depending on what specific model you have in mind, we're gonna have to address the policy issues, right? Because you want to have some control, presumably, or get some priorities on it since it's your hardware, and we're gonna have to address some environment portability issues and how that fits into the general systems. But yes, we'd be delighted.
Okay, I want to add something because this is part of the sustainability model. So at UTSA, we actually put a model, and actually we built the first. I don't know how many people they are familiar with. It seems everyone knows OpenStack, but there's another movement happening in the industry on the hardware side. They call it Open Compute, which is started by Facebook, and every single big company right now they are moving to that one. They are bypassing the Dell of the world, the HP of the world. So. What we did, we basically, as part of the sustainability and bringing industry to the table, because there's a lot of interesting innovation happens in industry. And, as part of UTSA, we created a lab that actually certification of a lot of open compute. For example, Facebook, when it works on Uni network, which it's completely different the way, they build the infrastructure from everyone else, or Google. All the certification right now from Taiwan gets shipped to UTSA. We do that. So we kind of put a model together. I love to actually explore it. We're hoping this is a way that actually will bridge the gap as we come to the sustainability next level. So I love to basically talk to you and see what you have, because we have a lot of those already coming. That's why the education I mentioned, I have a big size, I could help. It's just because of all those donations.
So I just wanted to raise another alternative, right? So if you have a piece of equipment, maybe it might be appropriate for you to use a federated model, right? So both of these projects have federation interfaces, right? And I mean, if you have a rack or of specialized equipment or something like that, that might be the way to contribute, right? And use it in conjunction with either one of these projects.
Yeah, I was going to say basically that, but I do want to expand it and say, so the software that we're using to run ours, the Emulab software, if you count all the Genie racks and the Instant Genie racks and stuff that are out there, it runs something like 60 to 80 clusters. And so, if you have a small amount of hardware, consider sending it to us. If you have a large amount of hardware, consider standing up this software, running it on your own, but then opening it up to other people, by turning on this federation interface.
All right, so we'll wrap up here. I think you guys now know who to time to get them taken care of now, and we'd like to go ahead and thank the panelists.